Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt, because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is the Dutch Quali 26 appetizer, and this was for the Dutch, I think, Puzzles Masters, which occurred in March, I believe. Or at least I know the qualifications occurred in March. I'm not sure what else happened then. But anyways, this was, I think, one of the ones that did not make the cut for the actual puzzle qualifiers. And this is a Sudoku sandwiched end sums. And this is by Richard, who I think is one of the organizers of the Dutch puzzle thing or majigger. Anyways, let's get to the rules. We have apply classic Sudoku rules, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits. I don't know what, I couldn't say that right now. I can't say that either. Contains the digits 1 through 9 exactly once each. In each row and column, exactly n digits are placed between the digits 1 through 9. And those are the sandwich digits. So that's typical sandwich Sudoku. Clues outside the grid indicate the sum of all sandwich digits in the corresponding row or column, where n is the first sandwich digit from that side. Okay, that's interesting. So that means, say in this column, we have the digits 1 and 9 in some order here, right? That actually won't work. So we have 1 and 9 here. First of all, the digits in between the 1 and 9 add up to the number that's outside of the grid. So the digits in between would have to add up to 22, which is why I could not have 1 and 9 there, because 3 digits adding up to 22 it must contain a 9 with it if they are all unique, which they are because it's normal Sudoku. So, but anyways, the digits in between the 1 and 9 must add up to the number that's outside of the grid, and the number of digits that are between the 1 and 9 has to be the first digit that is sandwiched between the 1 and 9, starting from the clue looking in that direction. So in this case, it would be 4, because there are 4 digits sandwiched in between the 1 and the 9. And then these 4 digits must add up to 22. And those are all the rules. Or that's an example of how these sandwich end sums work. And those are all the rules. If you like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay, we have 32 is the most restrictive, because to have 32, you have to have the only possible combination that can add up to 32 between a 1 and 9 is every digit except for the 3. Right? Because the digits in between, the digits not including 1 and 9, all add up to 35 at most. And to subtract 1 out, in order to subtract enough out to get out 3, you have to subtract out specifically the 3. Because there's no 1 you could subtract out, because it's, again, these are the digits 2 through 8. And so therefore, the digits in between the 1 and 9 must be 2, 4, 5, 6, 7, 8, which is 6 digits. So that means either... So let's mark the possibilities for the crust, which are the 1 and the 9 for the sandwiches, can only be... We can't have any of these be crusts. And so the crust can be either here or here. The thing is, though, where can the 6... We know there has to be a 6. And so it has to be one of these two then, right? If we have crust here and the crust here, there's 6 digits in between, and that's a 6. If this is crust and crust, this must be the n for that portion. So we know in this case it's a 6, right? Now the interesting thing is we have something similar here for the 30, but we are less restrictive on that. To add up to 30 for the digits between 1 and 9, which would be 2 through 8, you could be missing a 5, or you could be missing 2, 3. So where can the crust be in column 1 then, if that's the case? You have to have 5 digits at least in between, because you cannot have... you can only be missing either a 5 in between the sandwich, or a 2 and a 3. Which means these 3 cannot be crust. Because if they were crust, it just doesn't work, right? You can't have 5 digits in between this digit and that digit, or this digit and that digit. Same with this digit, right? This digit cannot have 5 digits in between any of the cells in there. So since these cannot be crust, where is the crust in row 6? It has to be here. So this is crust, which means it's not green, and this must be the green. So therefore, this is not green, or not. This is not crust. This has to be crust here. This is not crust here, so this is 6 here, and this must be 3 here. So because there's 3 here, that must be in between the crusts here. So we must have 5 on the outside. So again, then that means we have 1 digit outside of the sandwich, which means this is a 6 also here. So again, either of these are the 6. I think this has to be not crust here. 1 is a crust, so that's always going to be crust there. This is a crust. You could have 2 here and then crust here. That is potentially possible. What we know is, though, that these can't be the crust because you need to add up to 15. These can't be crust, so that means one of the crust is here in box 3. Or sorry, box 4. So you can have... How many digits can you have in between? Can you ever have 4 digits in between? 2, 3, 4, and 6 could be. So any of these could be crust, and this could be crust here. Okay, so this is crust here, which means it adds up to 9. So that's at most 3 here. You can't have 1 digit because 9 is never included in the sandwich sum. So these can't be crust, these can't be crust. This could be crust, this could be crust, but this can't be crust. Okay. Okay. So this must add up to 18 here. Which means to add up to 18, you can't even have 2 digits, period. Add up to 18 in the same row. So it must be 3 no matter what. Digits in between the sandwich. So this cannot be crust, because if it's crust, it doesn't have 3 digits in between that and the other additional crust. Same with this. If this were crust, that doesn't work, because you can only have 2 digits at most in between that and the other crust. So we either have here and here, or here and here, or these 2. So that means the end digit has to be one of these 2. And it's either 3 or 4. We're not sure which. Okay. The green digit can either be here or here. Oh, this can't specifically be 4. Because if this were 4, the problem is that you would have to have 4 digits in between. 1, 2, 3, 4, but then that can't be a crust. So that's not possible. So one of these two could be crust, or this one could be crust. So if this one's crust, it's 2. If this one's crust, it's 3. If this one's crust, or sorry, not crust, the end sum. If this is the end sum, it's 2. If this is end sum, it's 2. If that's end sum, it's 3. Okay. You can't have 7 and 8 here. Because... So this can't be crust and crust, because again, this would be 7 and 8, but the first sandwich digit would have to be 7 or 8, which is obviously not going to be valid. So then the crust has to be before, and it can't be just 2. So it has to be 3 or 4. So one of these two is going to be the n. One of these is crust. This can't be crust because we can't have 2 digits again. So if this is crust, it's 3. If this is crust, it's 4. That's interesting. Hmm. Okay. 23. For this, we're gonna have to have... One of these two is definitely crust. That's interesting. This combination has to be 2 and 3, because again, n has to be the first sandwich digit, and you can't have just a 5 by itself there. You can't have a singleton at all. To add up to 8, can you ever have 3 digits? The answer is no. So it has to be 2 and 6 in this direction somewhere. So therefore this can't be green because that would be 2 and 6 there. This could be green. These obviously can't be green, so green could be here potentially. Can't be here because that would be 2 and 6 there. Green could be any of these. No, it can't be here because again it's the first sandwich digit. So we need a crust before it. Okay. 4 digits. So if it's 4 digits, can this actually be 4 digits here, adding up to 15? And the answer is no. Because if we had 4 digits, the remaining 3 digits would have to be 2, 3, and 6. But 3 and 6 both cannot be here because we have a 3 and 6 in the box. So therefore they would both have to be that digit, which is not possible. So this cannot be the end sum, which means this is the end sum here, and this must be the crust. So there's no more crust in column 2, and this is a 3. So that's 3, which means this can't be 3. So that can't be the end sum, which means this must be an end sum. And the crust has to be 2 and 7 here. Actually, that's not true. We just know one of these is 2. My apologies. This could be 2 or this could be 2. That means we have to have a 7 here or here. We're not sure which. So this must be a 2-7 pair, adding up to 9 between the crusts. These two add up to 15 minus 3. So this must be 12. Cannot be 3, 9. Could be 4, 8, or 5, 7. So either of those work. And the rest we don't really know. Okay. So one of these two is going to be crust here, which means we do not have crust in the rest of the box. Because we have 2 crust already in box 1. Can't be here, because if that's crust, this is not going to sum up to 16. So it has to be at least... green is one of these two. You can't have just 2 digits adding up between 1 and 9 to add up to 16, because that would require 17. Therefore, this must be crust here. Since this is crust, this has to be crust here to leave out a 5, because we can't be missing a 2 and a 3. So this is not the x sum, which means this is, sorry, n sum. This is not the n sum, so this must be the n sum here. So that's 6. This is obviously not a crust here. This must add up to 23 at least, which is for digits between 2 through 8. Has to be at least 4 digits. So this cannot be crust, but this could be n sum here. So any of these could be n sum. Except, okay, so this has to be 2 and 6 to add up to 8. So this must be 2 and that's 6. So no blue here. These can't be green anymore. 15. That's fine. Can this actually be the n sum? 6 digits adding up to 23 without a 1. That's not possible. That's 2 through 7 minimum, which is 27. So this can't work here. So if this is the n sum, it would have to be 5. If this is the n sum, it would be 4. Okay. That's okay. We have all the crusts in row 1, so that these can't be crusts anymore. So if this is the n sum, it's 3. If that's n sum, it's 4. We can't have 5 because we don't have a 1 available to add up to 16 for that. One of these two is crust, one of these two is crust. We don't know which. The n sum could be any of these digits, and it must be 2 in each case for row 9. Okay. So this cannot be crust, because if it were crust, then this would have to be 6 digits in between, adding up to 23, which is not possible, because 7 digits between 1 and 9, not including 1 and 9, add up to 35, and 35 minus 23 is not a digit. This can no longer be crust, because if that were crust, well, okay, period, we can't. So these two cannot be crust, because if those were crust, it's just too big for the digits in between the crusts. This is 14. So between the crusts, well, you can't have 5. So that's not possible. So then these can't be crusts. And you can't have 1, obviously. You can't have 2 either, because 2 plus itself 2 plus another digit is never adding up to 14. So this must be the end sum. This must be the crust. So that eliminates crust in the rest of row 5 because we have 2 crusts. And therefore, this is 9. This is 1. That's 9, which makes this 1. 9 eliminates 9 from being here, so that's 1. That leaves that as 9. And this must be 3, so that these 3 digits add up to 14. So the possibilities here are what? 2 and 9. No 3 and 8, because they add up to 14 minus 3, which is 11. 4 and can't be 2 and 9, because there's 9 cannot be in between. So it's 4, 7, or 5, 6 here. Okay. This is a 3 here. So that means this can't be green. This is green going that way, but not this way. So this cannot be a 3 here. That means it's not green there. It has to be green going here. So this is 4 going this way, which means this is crust here and this is crust here. This is crust as a 1 and this is crust as a 9, which means if this is crust as a 1. The 4 digits in between must add up to 18. And we already have 4 and 3, so the remaining 2 digits must add up to 18 minus 7, which is 11, which has to be a 5, 6 pair. So no 4 or 5 remaining in the rest of row 4. And this is 2, 7, 8. We have 2, 7, 8 as possibilities here. This cannot be 7. If this were 7, where would the 2 be? It would have to be here, but then the 2 and the 7 would not be available to add up to 9. So this can't be 7. This is really 2 or 8. This can't be 7 or 8 here. It's 4 or 5, adding up with the 7, 8 there. They add up to 15. With the 3, we have a 5, 6 pair here, which eliminates 5 and 6 in the rest of the box. So this is 2, 4, 7, 8. Okay. This is 4 going that way. It does not have to go this way, but it could. We're not sure completely. So this is done. This is done. Well, not quite, but it's pretty much done. This is kind of done. This is done. 16. So it could be 3. It could be... Can it ever be 4? Maybe. What about 22? This is 1. We need a 9 here or here. We're not sure which. We need a 9 in one of these 3. 1 has to be 1. Okay, this can't be 1 because of the 18 sandwich clue. So where is the 1 in box 3? Can't be here or here because of 1's in the column. Can't be here. Oh, sorry, 1's in the row. Can't be here because 1 in the column. So 1 has to be here. This must be either 3 or 4 adding up, and we can't have 1 here. We can't have 1 here as the n, so this must be the n going that way, and it must be 3. And so wait, this would be crust then in that case. Okay, so no, it cannot be, this can't be the n here. It has to be the n here, which means this is crust here. So this can't be n there, which means this must be the n here, and that must be the 2. So this is not any of those. This must be crust. This is not crust. This is not crust here. Because of crust, we have 2 crusts already in row 9. So this is 1, which makes this 2. This is 2 and 3. This is 9. That eliminates crust from the rest of the column because we have 2 crusts in the column. So crust of 9 has to be one of these 2. 1 can't be here as crusts because of 1 in the row. We can't have 9 here. So one of these is 9, which means this can't be 9 because of 9 in the column. So this must be 9 here. And this is 4 here as an end sum. This is 5 here as an end sum. Okay, so 5 eliminates 5 here, so that's 6 and 5. This is an end sum going that. It's kind of confusing with all the end sums. This has to be crust here, and that's 9. So to add up to 10, it can't be 3. It has, because if we made it, well, first of all, there's no crust available here. So this has to be crust here, which is a 1. And this must be 2 and 8 to add up to 10, because we have 2 as the end sum here. So this cannot be 2 as an end sum, and we also can't have a crust here. So that's doubly removed. Therefore, this must be 2 here, and this must be 7. So that's 2 as an end sum. This is obviously crust then, and it must be 9. This then can't be crust because we have 2 crusts in the box. So this can't be the end sum going this way, so this must be crust here, which means that's end sum going this way, which is 3. This can't be crust here. This must be an end sum, and that's 4 digits in between, so this is 4. This is a 9, so we should have all the crust available, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's check. We have 3 for the end sum there, 4 for the end sum there, 2 for the end sum there, 2 for end sum there, 3 here, nothing here, 4 this way, 6 this way, 2 this way, 5 this way, 2 this way, and then 6 up, 3 going that way, 4 going that way, and 4 going that way. Okay, so now let's add up for the sandwiches. This is still the same. This is still the same. 8 eliminates 8 here. Where can 2 be in column 4? Can't be between because of the sandwich. Can't be here because of 2 in the box, so 2 has to be here. Which means this can't be 2 or 4. This can't be 2 or 4. This can't be 7 because of 7 in the row. So this is 8, which makes this 7. This has to be 4, 7, or 5, 6, and it cannot be 5, 6 because of 5 in the box. So this has to be 4, 7 here, which makes this 5, 6 here to add up to 14. We have 4, 6, and 8, which adds up to 18 here, so we need a 2 here to add up to 20 in the column. So that's that one, that one, that one. 22. We don't have 2 within. We have 4 digits adding up to 22. 22 minus 4 is 18. These specific digits remaining in row 6 are 5 and 8. Okay. That means the remaining digits in this box 6 are 3 and 6. 2 eliminates 2 from being here, so it's 7, 8 as a pair. This is 2, 4, 5 as a triplet, and this can't be 2 because of 2 in the column. So where is the 2 in row 5? It must be there. Remaining digits in column 1, we have 7, 8, or 4. Okay. Remaining digit in box 8 is a 6. So that's 6 here. Remaining digit in column 6 is a 7. And the remaining digits in column 5 now are 4 and 8. Okay. Where is 5 in column 2? Can't be here because of 5 in the box, and these are all filled out, so this must have a 5 here. So this must be 5 and 7, adding up to 12, which with 3 adds up to 15. So 7 eliminates 7 here, so it's 8. There's no more 8 here. It's a 4-7 pair. 5 eliminates 5 there, so that's 4. Remaining digits in column 2 are 2, 4, and 8. And this can't be 2 or 8 because of 2 or 8 in the row. So this is 4. This can't be 2 or 4 because of 2 or 4 in the row. So this is 8. Therefore, that makes that a 2. 4 eliminates 4 here, so it's 7 and 4. Remaining digits in box 1 are 5 and 8. Remaining digits in column 3 then would have to be 3 and 7. And this can't be 7 because of 7 in the row. So this is 3, which makes that 7. That leaves an 8 remaining in row 8 and a 6 remaining in row 9. Remaining digits of row 7 are 3, 5, and not 6. 3, 5, and 7. This can't be 7 because of 7 in the column. Remaining digits of column 9 are 3, 5, and 4. This can't be 3 because of 3 in the row. Okay. So this has to add up to 22, and this must add up to 18. Interesting. What are we guaranteed here already? So we have 4 and 4. So these must total combine add up to 40. We have 4 and 4. That's 16. No, so that's 8. 8 plus 3 and 6 is 9, so that's 17. Plus 5 and 8 is 13, which is 30. So these two must add up to 10, which means it's a 3 and a 7. Because 40 minus 30 is 10, right? So that leaves this as a 5. This can't be 5 here. It's 4, which makes that 3. That's 3 in the corner. We celebrate because we're close to solving it. 4 eliminates 4 here, so it's 7 and 4. 4 eliminates 4 here, so that's 8 and 4 there. 8 eliminates 8 here, so it's 5 and 8. And 5 eliminates 5 here, so it's 6 and 5. And 3, 5, and 8 does add up to 16. Remaining digits in row 2 are 2 and 6. And this can't be 2 because of 2 in the column. So that's 6. This is 2. 6 eliminates 6 here, so it's 3 and 6 there. 3 eliminates 3 here, so it's 7 and 3. And this must add up to 18. We have 4, 3, and 6. And so therefore this must be 5, which makes this 8. 4, 3, 8, 7. Does that add up to 22? Yes, it does, because 7 plus 7 is 14, plus 8 is 22. That leaves this digit as a 7. That leaves that as an 8, which leaves this as a 5. And that's how you solve it. Pretty cool, actually. Never really ran into this n sums interactions with the sandwich. So that was interesting how that interacted. It definitely did restrict things more than like your typical sandwich clue. So that was interesting. It's interesting to see if this could potentially be used in the future more. Possibly. It is really restrictive, though, on the first digit. So maybe not. I don't know. It's hard to say. Interesting puzzle, though. And I hope you enjoyed this solve. And I'll see you next time on Frank Puzzles. Take care.